Hello everyone, this is Chidanand from K8s Infotech NG and I welcome you to this short demo on Kubernetes. Kubernetes, which is running as a Minikube in my single node cluster and implementing a network policy using a CNI plugin called Cilium. Those of you who know the basics of Kubernetes, you'd probably know that any element or component, be it a pod, a service, or deployment, anything that is deployed within your cluster, irrespective of whether it's in the same namespace or different namespace, or however your traffic is spread out within your cluster, by default, all these components can reach out to each other. That is the guarantee that Kubernetes provides you. That is how Kubernetes expects elements to work. Now this may not suit many of your requirements. There would be use cases where you do not want few pods or services or deployments or anything that is specific to your application to be available to any other pods or services or any other Kubernetes elements that are running within your cluster. In all possibilities, if you have a huge cluster of 100, 200 nodes, your organization would have employed or deployed a lot of applications within this cluster. Now, how you segregate all these applications, how you demark each of these applications is left to the operations guys who will be running or who will be managing your cluster. But in short, you do not want a lot of your services, lot of your deployments that is specific to few of your customers to be available to everyone. Now, if at all you have a use case such as this, you definitely want to put out some sort of a network policy rules wherein based upon some criteria you want few of the services or pods or elements within your cluster to be made available only to some specific uh, Kubernetes elements that specify the given criteria. That is where you would go ahead and install or think about having a network policy for your cluster. Now, what I want to demonstrate is using Minikube, which is nothing but a single node Kubernetes cluster for setting up this whole thing. So by default, Minikube does not support any of the CNI plugin. So you would need to start Minikube with this plugin or with enabling this plugin and then go ahead and install the CNI plugin. And what I want to use for my demonstration is called Cilium. Is one of the available CNI plugins that is there, but the concepts are all the same. Any other CNI plugin that you're going to use, the YML definitions or the way you would want to define your network policy within your Kubernetes remains the same. What I want to demo in today's session is something close to what I've depicted right here. So I have Minikube, which is running my single node Kubernetes cluster. I will power it with Cilium and bring up my Minikube cluster. After that, I would create a namespace called Secured Apps. Now, by default, there's already a namespace created or called default, which is created, but I would want to create another namespace called Secured Apps. Within this namespace, I'm going to create a simple Nginx deployment. Now, I will expose this Nginx deployment as a service and also demonstrate to you that now if I just go ahead and expose this as a service. Now this service, which is actually specific to this secured apps namespace, is visible across all the pods or all the services in my cluster. So anyone on my cluster, if he knows the DNS name of my service, would be able to ping to it. I will be able to connect to it. Now I'll bring up a busybox pod in my default namespace, and I'll show you how easy is it for me to access this particular service which is running in a different namespace. Now after this, I'm going to define a network policy wherein I'm going to just set the ingress rules. Ingress is nothing but the incoming rule for your particular service. So for my service, who all can get into my service, that is my ingress rule. The egress is whom all can my service call out to, or whom all can my service reach out to. So this is the inbound rule, this is the outbound rule. So what I want to define is a simple ingress policy for my service that ties up few of those parameters, or which defines few of those parameters, based upon which only those guys who match my criteria would be able to get in, or would be able to reach my service. I'll show you two different ways of doing that. One, giving out namespace, and also adding one more label to my to any of the guys who are seeking out to reach out to my service. So if these two criteria are not met, then definitely this service is not exposed to them. So that's a simple tutorial or simple demo that I'm going to run. Now that I've told you what I plan to do, let me get started. All the source code that I'm going to use is present in one of my GitHub repositories, which is a public repository, and I'll share the repository link in the descriptions of my video. So I have all the instructions that I've given out here, which tells you how exactly to configure your Minikube. So Minikube version, I'm running this specific version of Minikube. How do I start my Minikube? This is the virtual driver that I'm using, and I'm specifying network plugin as CNI, and I'm enabling that enable default CNI. These are the two options with which I'm running my Minikube. And also I'm running a specific version of Minikube. I'm running Minikube version V 1.18.0. After this, I would need to install Selenium. Now there are multiple ways of installing Selenium. Cilium. Cilium is one of those CNI plugins that lets you or that powers the network policies around your Kubernetes cluster. So you can look at this documentation, and it tells you what all features are present in Cilium and how to install it as well. So I've given you this step. This is how you go ahead and install the Cilium, so that the Cilium will be running as a daemon set. Alright, now I've got all these things up and running. So let me just check if at all my Cilium related. It will take a while for your Cilium pods, related pods, to come up. So let me just check if at all I have it up and running. So K get PO, the namespace should be cube-system. Okay, so you would see these Cilium related and also the core DNS which are in a running state. So now you'll have to wait for some time before, if you're running it for the first time, before all these things get up and running. All right, so now I have Cilium up and running. My Minikube is running. Let me just show you the versions of Kubernetes that I'm having. I'm having client, nothing but the kubectl 1.18, and also the server is running on 1.18, and my Minikube version is v 1.10.1. all right, now what is that I would want to do? I would want to go ahead and create straight away a deployment. I would like to create a deployment, and the source code for creating a deployment is right out here. I'll quickly go through that, but I assume that you guys know about this, so I don't want to go too much into details of that. So it's a deployment. The name of the deployment is called Nginx deployment. I've got just a label so that I identify this deployment. The label is called app-tire, and it's a UI. And also, as I told before, I'm going to get all my control applications within this namespace, and I call this as secured apps. That is the namespace that I want to create. This doesn't exist now. I'm going to create this. Simple spec about the deployment. I would want 2 replicas. This is just the selector for the label. And what is that I'm running here? I'm going to run my Nginx, which will run on port 80. All right, now before I run this, I would want to create a namespace called secure apps, because I'm going to run all my control apps within this particular namespace. So let me go ahead and create that namespace. K create K is the alias that I've already set out for kubectl. So K create namespace secure apps. All right, sorry, I had it created earlier, so it's already there. K describe namespace secure apps. Okay, so this is there. So this should be fine for me now. I can go ahead and create my deployment. So K create apply is better -F. Okay, so now this deployment is going to be created in the namespace secured apps. So if I just go to K get deploy, probably not see anything. So I'll say K get deploy namespace secured -apps. All right, so now I have this. There are two pods that are running. So if I say K get deploy PO, you'll see there are two pods that are running. All this is in the secured namespace, secured apps. All right, so now the pods are running as part of my deployment, and for the deployment I mentioned that I would need 2 replicas, so that's up and running. So now let me expose this deployment as a service. So K expose deploy, the name of my deployment, which is nothing but nginx deployment, and this deployment is present in the namespace secured apps, and let me expose this on the port equal to 80. Great. So I went ahead and exposed this deployment as it will be the same name. If I say K get svc namespace secure apps. Okay, now this deployment got exposed as a service, and the name of my service is nginx deployment, and there's an IP address for it, and I did not specify what type of a port that I wanted it to be exposed, or what type of traffic I wanted it to be exposed. So by default it is the cluster IP that I've got. To summarize what I did till now, I created a deployment in the secure apps namespace. I created a service for this, and I've not yet defined any network policy as yet. Now what I want to show you is, let me bring up a simple busybox kind of a pod. I'll bring it up in the default namespace, and I'm going to demonstrate if at all I can find this particular service which is in the different secured apps namespace. So let me quickly bring up a busybox pod. All right, so K run. What I want to run? I want to run busybox. Let me see if I already have a busybox running. Okay, K run busybox. Image is equal to busybox. Restart equal to never. And what is that I want to run? I want to run this sh-c sleep for 1 day. Okay, and mind you, I'm not running this in that secure apps namespace. I'm going to bring this pod in the default namespace. So if I say kget po, you will find that my pod is just beginning to get loaded. It'll take some time for my pod to come up. All right, so my machine is a little slow, but this looks good. So my pod has come up, my busybox is already running. So let me try to get on this pod. K exec -it busybox -sh. All right, so I'm inside my pod now. So let me see if I can get to the service that is there in the other namespace. So wget-t timeout, I'll say 3 seconds. The service name was nginx deployment. This is the name of the service that I gave. All right, okay, it's not able to find my deployment. -t3 secured apps dot nginx All right, not able to find this. Let me try this way. Nginx hyphen deployment dot secured hyphen apps. All right, now this is the DNS name wherein you specify the name of the service and you specify the name of the service. My name of my service is Nginx hyphen deployment and dot and the name of the namespace. So if you see, he's able to reach out to the service that is present or running in my secured apps namespace. Now this is as expected, because that's the whole idea of Kubernetes, where any pod or any service or any of those elements that is running within your cluster would have a unique IP address kind of a thing, which the elements within the cluster can find each other and talk to each other without any issues. That's how Kubernetes is designed. Now, we don't want this to happen. I let this pod be running. So what I want to now do is I want to put ahead some sort of criteria, because I don't want my service to be visible for everyone. So I want to put up some sort of a rule for my service that is up and running. So let me show you that particular code where I go ahead and define my network policy. All right, API version, this one, the kind is network and capital P capital network policy. This is just a name for my network policy. And if you notice here now, this network policy is present in my secured apps namespace. But it doesn't matter wherever this policy is present. What is more important is where is or what are the criteria for which this network policy is applicable. So this network policy is applicable for all pods that have got this matching label. Okay, now if you have noticed, my deployment has got this particular label, app tire as UI. So this defines the criteria for all the pods or services or deployments that match this particular criteria. Okay, so now for my deployment and my service, which suits this criteria, this is the policy. And policy types, ingress is all that I want to define. If you want to define an egress as well, you add one more hyphen down here and then add egress. So ingress, and what is the policy that I want to define? Now I've got two criteria that I've specified here. Okay, so one, namespace selected. So only pods or elements that are running in the namespace that match this criteria, where the namespace name is secure apps, only that will have access or which can get into my particular um, uh, pod or service or whatever I've defined, whatever matches this criteria of mine. The other one is a pod selector. So not every other pod, within this namespace can get into it. I would want a specific label to be present, match labels. So only the pods which match this label saying allowed hyphen pod, yes allowed. So it's just a simple criteria that I put out, but you can think about any realistic scenario where you have different customers. Some of them are pods or services which have been authenticated, only those, or however you can think about all those scenarios. But in short, I'm defining a simple network policy where this is the pod selector, and any pods or any services that matches these label criteria all get tied on by this network policy. And in this network policy, I'm defining an ingress saying that only whatever namespace the pods or service or elements from the namespace secured hyphen apps, that and any pod that matches the criteria allowed, which has got a label allowed hyphen pod colon yes allowed. Okay, only these would have access to my service that I've exposed. Now let me create this. K apply hyphen F. Okay, now the criteria is applied, the network policy is applied. Okay, let me just check that. K describe network policy secured hyphen np, that's the name of my policy, and this is in the namespace. secured apps. All right, so this policy is set out, everything looks good. The pod selector criteria from namespace selector, pod selector. Okay, this really looks good. So my policy would be applied now, and Selenium would have ensured that now any other pod that is running which doesn't match these criteria will not be able to have access to the service. Now let me go back to my BusyBox pod, which was created in the default namespace, and let me check, because if you have noticed earlier, I was able to hit the deployment or the service that that was exposing the deployment. Now, after the network policy has been implemented, let me go ahead and check if at all I can hit that service. So K8s-IT, I want to hit BusyBox. All right, wget hyphen timeout 3 seconds, nginx hyphen deployment dot secured apps. Now if you notice, the security policy is in place. Now a pod which first of all doesn't exist in the secured apps criteria. So the secured apps, doesn't match the namespace. So this is not in the namespace secret, so it doesn't have access or it should not give access, which is as designed. So let me just get out of this and let me kill this pod. Okay, delete po busybox hyphen false hyphen grace hyphen period is equal to 0. All right, now let me create another pod within the namespace of secured apps. So I'm going to create another pod here in this namespace. Sorry, this is what I created. This was not running, or this doesn't have access as designed. So let me create one more BusyBox pod. This time I'll create this BusyBox pod within the secured apps namespace and check if at all this guy would be able to access the service. So K run BusyBox image equal to BusyBox restart equal to never hyphen n secured apps as the namespace. And what is that I want to do inside that pod? sh hyphen c sleep for Monday. All right, now if you notice, I'm creating the BusyBox pod in the secured hyphen apps namespace. So if I try this get po, I'll not be able to see anything. So get po in the namespace secured hyphen apps. Okay, the pod is up and running now. So let me try to get into this pod. K exec hyphen it BusyBox hyphen namespace secured apps. Okay, I've gotten into the pod now. Now let me try to do, it's in the same namespace, so I don't really have to add the namespace in the DNS name. So wget hyphen timeout 3 seconds nginx hyphen deployment. Okay, even this is not able to access the pod. The reason being, okay, now these two criteria should have to be met for the pod in order to access the service. So this is met, but this one is not met. So I need to label my pod as with these labels. So let me quickly do that. So K label po BusyBox in the namespace secured hyphen apps. What is that I want to label? Allowed hyphen pod equal to yes allowed. This is just a simple label. Okay, looks like it's got label. So let me say get po in the namespace secure apps All right, now the label allowed hyphen pod is equal to yes allowed. Okay, now this pod looks like it's properly tagged with this particular label. Now this pod matches, the pod is still running, so but it matches both these criteria. Now let me go ahead and check if at all I can get into this pod and see if at all I can hit this service this time around. Wget -t3 nginx deployment. There you go. So though the pod was up and running, the tagging the particular pod is what ensure that both the criteria for my ingress was satisfied, after which the pod is able to hit the service. Networking in itself is a pretty complicated and interesting topic in Kubernetes. As and when you mature through your application development and delivery in the Kubernetes ecosystem, you definitely have a need where you would want to explore all these options. So in short, I just quickly showed you how easy is it in order to use Minikube. As a developer, it's very easy for me to use Minikube, and unfortunately Minikube has to be configured in certain ways to support some of these particular features, to check these features before you go ahead and deploy them into a proper Kubernetes cluster. So in a very simple way, how to go ahead and use one of the available CNI plugins to power your Minikube single node cluster, and then use the Kubernetes network policy object that is available and go ahead and define simple rules wherein a pod to pod or pod to service across namespaces can be easily controlled. The Kubernetes documentation is extremely good in this topic. You can go ahead and have a look at this, where it shows you different kinds of options and YAML configuration that is possible, where you can go ahead and ensure that only specific subnet addresses for egress and ingress can very easily be put in as a part of YAML configuration. And hopefully I made that whole thing very easy for you guys to kind of configure. And as usual, I'll be putting up all the configurations that I used along with the source code in my details section of my YouTube. And if you have any questions or doubts, if you run into any issues while you're running this or trying out this, please leave a message and I will get back to you as quickly as I can. All right, finally, thanks a lot for watching this video. I hope it was useful. If not now, later definitely it will be useful for you. All right, thanks a lot.